Well, in Lesson 3.2, we're going to have an introduction to functions. And these are our objectives for the lesson. Equations in two variables define relations between two variables. There are other ways to describe relations between variables: set to set and ordered pairs. And a set of ordered pairs is also called a relation. Some relations are also functions. A function is a set of ordered pairs that assigns to each x value exactly one y value. Something to note here, a function is a special type of relation. So all functions are relations, but not all relations are functions. If we consider the x as the input and the y as the output, that might help understand. So given this relation, is it a function? Since each element of the domain, so the domain is x, we look at all those values, is paired with only one element of the range. So this 4 is not a 4 listed later on with another number. 4 goes to 9. It's okay that the -4 also goes to 9. The trick is, does this input have more than one output? And it does not. It's assigned only one y value. So this one is a function. How about this relation? Is it a function? Since each element of the domain, the x values, would produce only one element of the y, it is a function. Now let's look at this one. This is different because we have y squared. So since each element of the domain, the x values, could correspond with two different values of the range, because this could be positive and it also could be negative. So this relation is not a function. Relations and functions can also be described by graphing their ordered pairs. You'll see some more information about the vertical line test on page 133 in your text if you would like to turn there. Graphs can be used to determine if a relation is a function. If an x-coordinate is paired with more than one y-coordinate, a vertical line can be drawn that will intersect the graph at more than one point. If no vertical line can be drawn so that it intersects a graph more than once, the graph is the graph of a function. This is the vertical line test. So we're asked to use the vertical line test to determine whether the graph to the right is the graph of a function. So if you take your pencil and put it up in front of your computer, and you were to put it in a vertical line, does it touch that graph more than once? It does not. So since no vertical line will intersect this graph more than once, it is the graph of a function. Again, we're asked to use the vertical line test. So if you were to take your pencil and vertically lay it in different places, does it touch the graph in more than one place? No, it does not. So since no vertical line will intersect this graph more than once, it is the graph of a function. Now let's look at this one. A vertical line, if we take your pencil and lay it right along this line, look how it touches the graph twice. This one is not a function because it does not pass the vertical line test. Since the graph of a linear equation is a line, all linear equations are functions, except those whose graph is a vertical line. So if you've got an equation in the form y equals c, it is a horizontal line, so it is a function. But if the equation is in the form x is equal to c, it's a vertical line, so it is not a function. Recall that a set of ordered pairs is also called a relation. So the domain is the set of all x coordinates of the ordered pairs, and the range is the set of all y coordinates. So find the domain and range of this relation. When we list the domain, that's all the x values. It's a 4, -4, 2, and 10. So it's the set 4, -4, 2, and 10. The range is all the y values. 9. Know that there's 9 twice. You only list it once. If it's repeated, you only have to list it once. So 9, 3, and -5. Find the domain and range of the function that's graphed to the right using interval notation. Okay, so when we're talking about the domain, we're talking about the x. So on the x-axis, this goes from a -3, and it's included, see closed circle, and a +4. 1, 2, 3, 4. This one's at a +4. So the domain is from -3 inclusive to 4 inclusive. That's why we have the brackets. Now the range is the y value. This one goes from a 2 to a -4. So reading left to right, -4, 2, inclusive. Find the domain and the range of this function. Okay, this one's a little different. So let's look at all the domain values. This arrow says that it keeps going on indefinitely. So there are going to be any x values excluded. So the domain is -infinity to +infinity. Now the range is a different story. -2 is as low as it goes. It includes -2 and everything higher. So it includes -2 to infinity. Find the domain and range of this relation. Oh, look at there. Remember, x is our input, y is our output. Now, this is called a mapping diagram. We're mapping the input to the output. So the domain will be all the animals, and the range will be all the lifespans. Specialized notation is often used when we know a relation is a function and it has been solved for y. For example, the graph of this linear equation, y is equal to -3x plus 2, it does pass the vertical line test because it's a linear equation, x to the first power. So it represents a function. We often use letters such as f, g, and h to name functions. So we can use the function notation f of x to write this equation. So all we're doing, in place of y, we're just putting f of x. That's the only thing different. And it's read f of x. Note that the symbol f of x is a specialized notation that does not mean f times x. When we want to evaluate a function at a particular value of x, we substitute the x value into the notation. For example, f of 2 means to evaluate the function f when x is equal to 2. So we simply replace x with a 2 in the equation. Given our previous example, f of x is equal to -3x plus 2, we want to evaluate it for 2. So since we're going to evaluate it for 2, we're going to put f of 2. And everywhere there's an x, we're going to put a 2 and evaluate it. So notice when x is 2, y is -4. It gives us the ordered pair 2, -4. Given that g of x is equal to x squared minus 2x, find g of -3. So all we're going to do is substitute a -3 in for x. Now, this is just telling us what we're looking for. You don't have to do anything with it. All we're doing now is substituting a -3 in for x and evaluating. So g of a -3 would give us a -3, 15. That's our ordered pair. Given the graph of the following function, find each function value by inspecting the graph. Oh, wow, look at that. So f of 5 is 8. Now, this sort of cuts off up here, but if we go 1, 2, 3, 4, 5, over 5, it goes 1, 2, 3, 4, 5, 6, 7, 8. So apparently it crosses exactly. This must not be quite at 7. F of 4, 1, 2, 3, 4. Let's see where it crosses. 1, 2, 3. 4, 3. -5, 1, 2, 3, 4, 5. Crosses at a -1. And finally, -6 is at a 1, 2, 3, 4, 5, 6, 7. So our ordered pair on this one would be -6, -7. Very good. You're ready to begin practice on your own.